Have you ever looked up at the night sky and wondered, are we alone in the universe? This question has captivated our collective imaginations for centuries, sparking a sense of wonder and curiosity deep within us. Before we continue on this cosmic journey, please take a moment to like and subscribe to our channel for more exciting voyages into the unknown. The cosmos, vast and mysterious, beckons us to uncover its secrets and perhaps find answers to our deepest questions. The search for extraterrestrial life is not just about finding little green men or creatures from science fiction. Instead, it's about understanding our place in the universe. It's about finding a connection, a common thread that all life together, no matter where it may exist. This quest has led us to the exploration of exoplanets, those celestial bodies orbiting stars beyond our own solar system. As we gaze into the night sky, we're not just looking at stars, but potential homes for life as we know it, or as we could never imagine it. Join us as we delve into the fascinating world of exoplanet atmospheres and the search for signs of life. Before we embark on our cosmic journey, it's essential to understand what exoplanets are. Picture yourself floating in the vast expanse of the cosmos, gazing at the stars. Each of these stars could be a sun, much like our own, and around these suns, planets may be orbiting. These celestial bodies are what we refer to as exoplanets. Derived from the term extrasolar planet, an exoplanet is a planet that orbits a star beyond our solar system. Fascinating, isn't it? Now, you might wonder how many of these exoplanets are out there. Well, the answer is quite mind-boggling. As of now, we have identified over 4,000 exoplanets, and that's only the tip of the cosmic iceberg. Researchers believe that there could be billions or possibly trillions of these celestial bodies in the universe. These exoplanets come in various shapes and sizes. Some are small, rocky worlds, not much bigger than our Earth, while others are gas giants dwarfing our Jupiter. Some exoplanets orbit close to their stars, searing with intense heat, while others are icy worlds located in the far reaches of their solar systems. But why are we so interested in these distant worlds? The answer is simple: the search for life. As we gaze upon these distant planets, we can't help but wonder if any of them host life. Could there be a world out there with a civilization like ours, asking the same questions we are? The study of exoplanets is a rapidly evolving field. With each passing day, we're devising new methods to find these celestial bodies and study them. We're peering into the atmospheres of distant planets, looking for signs of life and unraveling the mysteries of the universe. With a universe teeming with exoplanets, it's not so far-fetched to think that life could exist somewhere out there. Who knows? The next big discovery might be just around the cosmic corner, so buckle up, space explorers, our journey is just beginning. Now that we know what exoplanets are, let's explore how scientists study their atmospheres. Our ability to study exoplanet atmospheres hinges on a couple of fascinating techniques. The first of these is spectroscopy, a method that's as intriguing as it sounds. Picture this. When starlight passes through an exoplanet's atmosphere, certain wavelengths of light are absorbed by the gases present, leaving a unique fingerprint in the spectrum of light that we see. By analyzing these fingerprints, scientists can identify the different elements and compounds in the atmosphere. It's a bit like playing cosmic detective, with every spectrum offering a new clue about the exoplanet's atmospheric composition. Then there's transit photometry, another technique that's a favorite among exoplanet hunters. This method involves observing the tiny dip in a star's brightness as an exoplanet passes in front of it, or transits. By carefully examining these transits, scientists can determine the size of the exoplanet and the composition of its atmosphere. It's like watching a cosmic shadow puppet show, where each passing silhouette reveals more about the exoplanet. But how do these methods help us understand the atmospheres of exoplanets? Well, the composition of an exoplanet's atmosphere can tell us a lot about its potential for habitability. For instance, the presence of water vapor could suggest the existence of liquid water, while certain gases like methane or oxygen might hint at biological activity. It's a challenging task, though. These exoplanets are light years away, and the signals we're looking for are incredibly faint. Plus, we have to account for interference from our own atmosphere and from other cosmic sources. It's a bit like trying to hear a whisper in a crowded room from miles away. But despite these challenges, scientists have been able to glean valuable information about the atmospheres of several exoplanets. And with every new discovery, we're getting closer to answering one of humanity's oldest questions. Are we alone in the universe? Through these techniques, we gain invaluable insights into these distant worlds. With the tools to examine exoplanet atmospheres, the search for extraterrestrial life truly begins. As we delve into the unknown, we turn our gaze to the skies, peering into the atmospheres of these distant exoplanets. But what exactly are we looking for? What signs could possibly hint at the existence of life? Enter biosignatures, the tantalizing clues that could lead us to the discovery of extraterrestrial life. Biosignatures are substances, often gases, that are produced by biological processes. They paint a vivid picture of the possible life forms that could be residing on an exoplanet. For instance, oxygen in our own atmosphere is a biosignature produced by plants and photosynthetic organisms. Here's the fascinating part. The presence of certain gases in an exoplanet's atmosphere could be a strong indicator of life. Take methane, for example. On Earth, this is a gas largely produced by biological sources like cows or decaying vegetation. If we were to detect a similar abundance of methane in an exoplanet's atmosphere, it might suggest the existence of life. But it's not just about spotting a single gas, it's about the cocktail. The combination of gases can be just as important, if not more so. Oxygen and methane together in an atmosphere, for instance, could be a smoking gun. They normally react with each other, and their coexistence might suggest a constant replenishment from a biological source. However, we must tread carefully. These biosignatures can also be produced by non-biological processes. Volcanic activity, for instance, can release gases like methane into an atmosphere. So the detection of a potential biosignature is not a guarantee of life, but rather a tantalizing hint that warrants further investigation. The search for life is not a simple task. It's like solving an intricate puzzle with pieces scattered across the cosmos. But with every piece we find, with every atmosphere we probe, and every biosignature we detect, we inch closer to answering one of humanity's most profound questions. Are we alone? The search for life is an intricate puzzle, but every piece we find brings us closer to answering the question, are we alone? While we've already made remarkable strides in exoplanet exploration, the journey is far from over. The future of space exploration is teeming with potential, and every new mission or technology brings us closer to understanding the mysteries of the cosmos. In the upcoming years, we're looking forward to a host of new missions. For instance, the James Webb Space Telescope, slated for launch in the near future, will peer into the atmospheres of exoplanets like never before. Its advanced instruments are designed to detect key chemicals that could indicate the presence of life, even from light years away. Then there's the Plato mission, a European space agency endeavor that aims to find and study a large number of exoplanets around nearby stars. The mission's high precision and broad coverage of the sky will allow us to examine planetary systems in greater detail. Similarly, NASA's upcoming Habex and Louvois missions are set to revolutionize our understanding of exoplanets. These missions will not only search for habitable planets, but also aim to directly image these distant worlds, something that's been beyond our reach so far. But it's not just about the missions. Future technologies like advanced propulsion systems and AI-based data analysis are set to play crucial roles. For instance, breakthroughs in propulsion technology could cut travel times to distant planets, making interstellar exploration a reality within our lifetime. And with the flood of data from these missions, AI is becoming an indispensable tool for sifting through the noise and uncovering hidden gems. The potential for future discoveries is immense. We may find planets with conditions suitable for life, or even detect signs of extraterrestrial life directly. We could discover new types of planets or learn more about how planetary systems form and evolve. The possibilities are as vast as space itself. As we continue our cosmic journey, who knows what we might uncover next? So, what have we learned about our quest for extraterrestrial life? We've traversed the vast reaches of the cosmos, albeit virtually, and delved into the enigma that is exoplanets. These celestial bodies, existing light years away from us, hold immense potential for the existence of life as we know it. We've discovered how scientists painstakingly study their atmospheres, using advanced technology and complex calculations to decode the secrets they hold. We've also taken a deep dive into the methods employed in searching for signs of life. The presence of certain gases, the temperature ranges, and the location of these exoplanets in their respective habitable zones, all these factors and more are considered in this fascinating search. While the question remains unanswered, the possibility of life beyond Earth continues to captivate us all. Remember, the next time you look up at the night sky, you're staring into a universe full of possibilities.